Uh, Victor is here as well, so I guess you can start recording. Okay, so it's start recording. So today we are going to learn how to separate out some part of your app to framework. So let's say, imagine you want to build application for iPhone, for Apple Watch, for Apple TV, maybe even macOS. Like all these platforms are in some sense different, but some code you can share. Basically, usually you share this like logic code. So which are the brains behind your apps, not per se UI, although you can sometimes share that as well, but mostly these brains. And let me share the screen, and I will show you the app what we are going to build today. So this is the end result. Hopefully you'll get it. And it's a calculator, but it's not so like simple calculator. It's using this Polish notation. So basically you add one, then you say, okay, I want to add one, then you add two, and then you say only like after these digits, these numbers, you say what kind of operation you want to perform. So let's say you want to add those two values. And then you see 1 plus 2 equals 3. So it's not like the regular calculator. And yeah, we will do that. We will separate the logic of the calculator in the framework. So then you can write unit tests, which we will not go into today because we don't have so much time. But separate app, iOS, we will use this framework. So in essence, you could build also Watch app or even macOS and maybe even Apple TV. So that will be the end result. But we'll go and start with the Xcode, creating new project. So file, new project. So go ahead and do that because we don't have any starter project today. So we'll do everything ourselves. And here, select iOS and select here frameworks. There's frameworks and library, and select framework. So press next then. Then let's call it RPN. So it's this calculator brain framework. And select language Swift if it's not by default. Otherwise, it can be quite confusing. Don't include unit tests because we will not cover that today. Then press next, and I'll save in one folder. You can create a new folder for today because we will have actually two separate projects in the same folder. So just press create. Then we can actually close this, what we did right now, the Xcode. I will drag my this finder inside. So as you can see, here's RPN project. That's it for now. So now let's open again Xcode, file, new project. And this time, let's create single view app. So basically, now create app where we can use this framework, what we just created. So select single view app, press next, and let's call it calculator. So language Swift, use storyboards, all these core data and whatnot, unit tests, UI tests, leave them unchecked. So next, and save in the same folder. So it has the same kind of structure. You can save somewhere else as well, but for simplicity and for easier to follow today's lesson, save in the same folder. So great. Okay. And now, please close this RPN framework what you had before. Otherwise, it wouldn't allow to do the next step. So have only in your Xcode calculator project open. And what we are going to do is create new. Let's create new group. So we will gonna import our framework. So basically another Xcode project. So make new group and let's name it framework. You can move somewhere down here, but it doesn't matter that much. And what we want to do is go to the Finder, expand this RPN, and drag and drop that thing inside here, frameworks. But this Xcode project, not the whole folder, right? So only this RPN .xcode project. So let's drag and drop inside here, and you can see that it's here. So everyone has like that. Otherwise, it could be quite confusing. So can you expand and see everything in Xcode? If someone has issues, then let me know. We can try to fix. Okay, if no one tells anything, then I assume that all is fine. And as always, you can ask me questions on the way if it's on the point, and if it's something not out of the context. I know what is Xamarin or versus iOS. Let's leave that for end of the lesson. So now we can slide out this Finder because we don't need it anymore. Okay, so as we are here, we can see that we have our main application with all the view controllers, the main storyboard, what basically Apple gives us. And then we have our frameworks folder, and then we have this RPN framework. And essentially, frameworks, what they consist of source files, sometimes also UI, but today we don't have UI there. And it has this info plist, what we have also in our applications usually. So all the like what the development language and blah blah blah, these things, what it usually is. And then we have our header file if we want to use this framework in Objective-C projects. So I think next week or next weeks you will learn more about Objective-C. So that used to be language before Swift, which all the iOS and macOS apps were built. So yeah, so basically you can create framework which can be consumed by Objective-C applications, because quite many applications are still written in Objective-C, because that was Swift is quite new language. So that's it about this file. We will not touch that more. And so we have our under products. So we can see RPN framework. So and that's what we are going to use in our main application. So now you can just press Command B, so it will build the project and the framework. So don't you can run as well, but build is just enough, because just it will build the underlying framework. And if we go, for instance, here in this view controller, we can write import RP. Why it's not there? I think I need this one. Let me. Yeah, so here you need to select RPN, and then you can select simulator. But let me give 1 second, maybe specify that thing. Yeah, I guess we need to, yeah, here, be careful that select this RPN, because it's separate framework, and then you can use iPhone Simulator. And once you build it, then I hope, yeah, then you can use it in the main application. So basically, as the frameworks are separate modules, they need to build separately. So let's keep here RPN for now. So in the first of the part of the lesson, we will work only with the framework. So here, select not calculator, but RPN, and one of the simulators you are going to use to run the app. And now let's go to back to the framework. So as we don't, it's quite empty, and let's start to create files what we are going to use to run our app and or calculator brain. So first, let's create a new file, and that is just Swift file. And let's name it stack. So I think in computer science questions you will cover in next weeks, I guess. But basically, stack, what it is, it has it's an array, but you can add to the top and you can remove from the top values. So basically, to array you add to the end, and then you can remove from end, basically. So stack is kind of reverse, but you'll gonna create from the code, so maybe it will make more sense. And I will write some comments inside the file, so you can have quick glimpse there as well. So let's name it stack. Great. And again, be creating this right folder, and also see that this target membership is for the framework, not for the main app. So we can slide this thing out so we have more space. And all this framework, what it's going to do, it will have this calculator brain, which is reverse Polish notation. So I will not go into details so much, but if you Google this thing, and you can read in Wikipedia long article how it's actually built, but we can see I have it here. So as you can see, it's postfix notation. So it adds this add after these numbers. So it doesn't like add 3 plus 4, but 3 and 4 and then plus. So that's how it works. And to make everything work, we need a stack. So basically what it is, imagine we can add, here is the end, and we can add, for instance, A, we can add like 5, W, 9, and we can remove things as well. And once we remove, it removes from the top, like the latest what has been added. So basically you add to the top and you remove from the top. So I can write it here, add to the top, remove from the top. So that is stack. And for that, let's create a struct. So we are going to use struct, not the class. And we can write stack. And it can have generic elements. So we need to specify just element. So whatever element will it be, we don't care at the moment, but it can have elements. And it conforms to expressive by array literal. And what does it mean? This thing which I have even problems to pronounce, expressible by array literal. So it means that if you have, for instance, array like 0 and 1 consists of just 2 digits. So this is this whole thing inside is expressible by array literal. So for instance, we can create stack array using or stack. We can write that it's stack, and then we can specify the elements what we are going to do be in the stack. So basically, we say that it can be expressed by array literal. So that's why it conforms. And now it's telling that as it conforms to this thing, we need to add some protocol stubs. So let's add. And there's only one thing which we need to add, which is array literal element. And what it's going to be, it's this element, a generic element, what we don't know yet what it's going to be. So let's see if it builds. Yeah, and second thing, what it requires is initialize method. So we need we can initialize using this element dot dot dot, and what it means is that we can it's variadic type. If I hope I pronounce it correctly. So it means that when we initialize, so for instance stack like that, we can tell that it's 9, 10, 11, and it will create basically array of these numbers. So it doesn't tell that it's it can be one or multiple elements. So we don't need to specify array like this, but we can just tell it will be like that. So it's a bit simpler shorthand way, so we can have one or multiple. So I would say like that. So is this thing understandable, or you already have covered in previous lessons maybe? Okay, and next thing we need or variable where we will keep the elements for internal use. So we can write var elements, and what it will be just an array of element, and that's it for now. So to work for the stack, we will use actually behind the scenes the Swift array type. And what we want to do with the stack, we want to push the items. So for instance, we have our stack, it's empty. So we want to add, for instance, 9, 2, 1. So we want to push. Then we want to pop. So what it does, it removes, for instance, 1, this 2. And then we want to have peek, which is just get the last element. So basically, we want to just look what it is. We don't want to remove from the stack, but we want to see what it is. And for that, we can create 3 functions. So as we are mutating this stack, are going to mutate. And here we need to fill the initializer. And where it is, it will just add all these elements to our element variable. And that's it. So now let's write the push method. So mutating func push. Mutating means that we will mutate the type itself. Push. So we don't want to specify when we call push name element, so we can have underscore here. And this underscore, by the way, means that once we call push, we don't need to write element like this, so we can get rid of this thing. So we can just write like this, and it's much shorter and more descriptive and understandable, I would say, as well. It's more characters, more code, and more stuff what potentially can break. So we want to add this one element to our array. So in internal array, append element. So we are adding to our array. Then we want to remove from the stack. So basically, we want to remove here from the top. So it's again mutating because it mutates behind the scenes the stack. Pop element, and here it's important that it's optional, because if there's nothing here, then there's nothing to return. So that's why it can be nil as well. And then elements pop last. So that's array function which pops the last element. And here it's important. In previous Swift versions, you had to write a return here, but from Swift 5.1, you don't need to write this return anymore. So if it's just one single line, compiler will help us and will understand, okay, that's what we want to do. And I can write here, so basically remove from the stack and then add to the stack. And then we want peek, which means let's go to the stack and let's look what's here, what's on the top. Again, it's optional element. And we have element last. So last just goes and checks what it is, but it doesn't remove from the array itself. So know what is at the top of the stack. So it just to see, not remove. So we are not going to remove, we're just seeing, and that's it. So we have our stack ready. So any questions here about the stack, how stacks work behind the scenes before we move further? I assume if there's silence, then everything is either clear or nothing is clear. So I hope kind of everything's clear. So don't be shy, ask questions. I will try to explain. And if you have maybe some issues in your computer, you can always you can share the screen and look what's happening there as well.
Percept, what happens to pop last if there's nothing left in the stack?
That's why here is optional. So it returns nil.
Okay.
Yeah, and it's the same here as well. So don't remember, put here optional. So if there is nothing, so but for instance, we don't have anything here, it just returns nil and that's it. Yeah, that's a good question. Because sometimes these question marks, you know, it's so easy to miss them. Okay, so next thing we are going to create is our digit accumulator. So let's create new file, and then I will go into details what it is and how we can create it and actually use it. So let's create new file, again in our framework. Next. And here as well, see that it's in the folder RPN, and the group is RPN, so in the framework. Otherwise, might be hard to understand what's happening if there is error. So let's call it digit accumulator. Okay. So we have a file, and what it in this where I have the Safari. So basically, in this reverse Polish notation, we want to keep the digits, and also we want to keep the operator as well. So as we need to get it working, we need a structure what we can actually use it. So for instance, we if we have like in the example I showed you, we have one, we added one, then we added two, and then we added plus, and when we tell, hey, let's calculate everything, then what it does in the end, it replaces this one with just 3. So we need structure, but we can actually keep track of all these things, that keep track of numbers, of these operators. So yeah, so let's start to create it. So we need struct, but here it's important because we want to make it public. And why public? Because we want to use it from our main app. And actually, stack what we created before, it's just internal in the framework. Here, for instance, we if we have here, we don't have access to the stack. So because it's only used behind the scenes by the framework itself. So we write public struct digit accumulator. And here I want to briefly explain about these access controls. So I write here access control. In the materials you saw multiple ones, and basically how it works is that we have our private. So if it's private, then it's only accessible by that module, and that's it. The next one is file private. Private. So it means it's inside the file. So if you have multiple structs in one file, then other structs can access those structs there. Then we have internal, which is actually default. And then we have public. And then we have also open, which is not so widely used in Swift projects. At least I actually haven't used that that much this thing myself. And I told you to tell me what it means this if you import testable on Monday. So so if you write a import, for instance, like that, what it means, it actually uses public as the default for testing purposes. So basically, all these like stacks and all that stuff, which is not usually accessible, will be accessible in your test environment. So that's this testable means behind the scenes. So it turns all the default to public. Okay, so we have, let's start working on our digit accumulator. And also we want to make the initializer public. So public initializer, which is actually just empty. And why we want it public available? So we wanted our main app or iOS app can initialize this digit accumulator. Otherwise, it doesn't have access to initialize even that thing. So we need to explicitly tell to the compiler that it will be like that. So we want that it is available for any app it imports this framework. So that's a small trick. And if you use testable, then it actually would make it possible to initialize in your tests. So next thing, we want to keep our digits. And what are those digits? So as you can see, it can be 1, 2, or plus. So for this, basically, if we have either, then it's usually enum. So we want to create public enum and digit. And we want equatable as well, so we can use it later. And what it can be, case. Sorry, or digits won't be plus, it will be one. So or numbers consists of like 1, 2, 3, 4, and like decimal point and something here. So not this one. That is job for stack. So basically, you want to keep or either it's decimal point or case number, and the type, what it can be, it's integer. So basically, our digits are 1, 2, 3, 4, 5. Then we have decimal point. We don't need to specify that that's a string because there's no need for that. 4, 0, and so on. And we want to keep our track of our digits. So let's create our digits array, and that will be private because we don't want to expose to outside, because we just want to keep it inside. And yeah, those digits can be created and accumulated only by functions which we are going to write in a second. So var digits, because we want to change those. That's why it's var. And let's create empty array of digit. So this thing is same as array digit. It's just a more shorthand way to write stuff, and more explicit that you want array of digit, and let's create it. So you can write here that it's internal use digits to keep track on. And so what we then want to do, we want to add digits to our digit accumulator. So we want now the public function, because we want to expose this to our main app, which whatever it will consume this framework. So public mutating, because you want to change those digits here. So it's mutating func add. And what we want to add is digit, and that is type digit. And as we are using type digit, that's why we want to make it here public. Otherwise, it wouldn't work in that way. And here, important that we want to throw. So here it's throws. So it means that something went wrong. We want to throw the error. So basically, what app or solution consumes this framework, it can throw error if something is wrong there. And we will write down here right away when we want to throw those errors. And here we want to use switch over digit. So as it is decimal point or number, so we can use switch and decide what we are going to do. And right away, compiler is telling switch must be exhaustive. So let's press here, fix, and bam, it has pre-filled stuff for us. We can remove this unknown because it's not needed at the moment. But we want to get, so for decimal point, we don't need to get any value because we know it's just point, and that's it. And what we want here is we want to see if digits has a decimal point, because we cannot have a number like that. It's like there will be math problem. What it is like, so it's something is wrong. So what we want to do is let's use guard if digits not contains decimal point. If it does, then we will throw error. And what kind of error we can create here outside or error. So we will not use the Swift error type, so we can create our own, and we will conform to error. So again, public, because we want to show these errors in our apps. Public enum digit accumulator error, and it conforms to error. And what it can be is case extra decimal point. And why I created here outside is that it's just simpler naming. Otherwise, if you would create here in the struct, then it would be like this digit accumulator. And here I have W, but okay, that's doesn't matter that much. Dot digit, like hold this thing. So we don't want so long thing, so we can get rid of this one. So we create it outside. Okay, and here we want to throw. So digit accumulator error dot extra decimal point. So if you have extra decimal point, let's throw. And maybe this is not so understandable. We can also write it if digits contains decimal point, then throw the accumulator error extra decimal point. So I will comment this out, but this if is same stuff here, because sometimes this not notation might be not so easily to spot. So I would say that if there is not in the beginning, usually it screams to kind of refactor in more readable way. Okay, so we have our decimal point, and here we want to see if it's a number. So we want to get the actual value. So here inside dot number, we can tell let value. So we want this value, we want to use it. So as it is for the enum, it can like have associated type, so that is integer. So basically with number, it comes also integer type value. So we want to get it. And then we want to check if it's like smaller than, it's not smaller than 0, and it's smaller than 9. So it cannot be more than 9. So because it's a digit, it's not a number. So let's use again guard value. It's greater or equal than 0, and value smaller or same as 9. If it's like 11 or something, then we want to throw the error, and again throw. But we don't want to use extra decimal point error because it doesn't make sense. So we want to actually create new case here. So we can use separate error for this purpose. So case invalid number value. Let's say that sounds a good idea. So here, digit accumulator error and invalid number value. So it's more descriptive like that. And how this thing is actually same as if value smaller than 0 or value large, yeah, if it's smaller than 0 or larger than 9, then something is not okay. So we can throw digit accumulator error invalid number value. So I will again comment this out so you can see how guards can be written. Basically, these ifs can be written as guards. And I just think it's kind of more on the straight line way, because we have guard, and if something is bad, then we right away throw the error. Otherwise, we continue what we need to do. So, and guards are usually used by Swift developers, so I would say it's good way to get familiar with them and how to use them. And then in the end, in the function, so make space here, we want to add to our digits this this digit what we passed inside. So append digit. So if everything is fine here in this switch, then we add to our digits this one digit. So basically, we add one. Okay, it's fine. We add two. We add three, and so forth. And that is basically called this thing. In the end, would be array of all these values. And now we need one a bit smaller function before we move to one bigger one. We want to clear this digit accumulator. So basically, we want to get rid of this thing. So if you remember or starter project here, so if you press like this X here, we want to get rid of all that stuff. So we want to create a function in our framework to do it. So to do it, we can write func mutating, and again, it's public, sorry, public. So it's important, otherwise we couldn't clear it. Mutating, vice versa, it's public mutating func like that. And we can call it just clear, so it's more understandable. And what we want there is digits. So basically, we're keeping track of all our digits here. And what we want to do is just remove everything from that array. So remove all does the job for us. So basically, if we have, for instance, 1, 2, 3, like that, clear will just empty array and make it empty and everything, and that's it. And the last thing what we want to do is we want to get the value. So if we have, for instance, this example, I'll copy paste here. So if we have like that, we want to get out 1, 2, 3, 4, 5, 40. So we want to get out of this array just one simple value. So again, public func value. So we want to get the value from this digit accumulator. So it accumulates all these digits and not these decimal points. And what it gets back, it's double, because this type is actually double. And it can be also optional. So be aware it can be optional. If something fails, then we just return nil. And here, any ideas how we can get from this kind of array to double here? So maybe it's simpler that we write that we have in the beginning, we have string, and then we convert that string to double. So anyone has any idea how we can do it? Just this one. This question can be usually it's like day-to-day job, and sometimes in job interviews, folks ask this as well. How, if you have array of like string values, how can you concatenate everything and even in the end convert to double? So that would be the problem we want to solve here. So anyone?
I watched one of the previous videos, so I feel like I'd be cheating if I gave the answer.
I mean, actually answer, if you have job interview, answer, hey, I don't know it, but I have resources where I can check it, or I know what it was called. It's much better answer than just silence. That I can tell for sure, because honestly, I don't know all the stuff as well. I prepared for this lecture, but I don't know all the stuff in the Swift world. So that's no shame that you don't know. But the thing is that if you know where to look, or hey, I just need the time to kind of experiment, that's really good. So usually programmers they need to know where to look, not just memorize everything, because no one can memorize everything. If you want to memorize everything, then you can even go nuts or something. So anyone has any idea how we can do it?
I've got an idea. Just using basically a string initializer, and then using each array's values, scripting each array value and putting commas between them.
Mm-hmm. But how we can go over all the elements in array? You are on the right track, that's for sure. Basically, we want to go to the first one, then we want to go to the second one, and then like add these two together, then the third one, add these three together, go to this one, add these together.
I didn't realize we wanted to add them together.
Yeah, because we want to, we have array here from these
Right.
things, then we want to get this out of all this array, right? And
right.
then
I mean, just put them all on the same line, not add the values.
Yeah. Sorry, yeah. Well, concatenate. So that would be a more precise term, I would say.
Right. Well, the only way I can think of is just doing it with, I guess, how many strings are 1, 2, 3, 4, 5, 6, 7, 8. Making one string out of all 8, like plus string, plus string, plus string, and then scripting each array value. So digits, or I don't know if those are digits, but array subscript 1, array subscript 0, array subscript 1, 2, 7.
Okay, I will not torture you. I will show how I would do it. So I would do that. We want to get out or strings. So at first, let's do this step. So as we have multiple steps, let's create from array just one value. So we can call those strings, right? So we have our digits, which is array of all these things. So that can be this decimal notation, or it can be digit, right? And we are going to use our higher order function called map. So basically what it does behind the scenes, it goes to the first one, it maps to something. What it maps to, that was your answer. So basically you will convert to string. It goes to second one and so forth. So we want here our digit. And again, we want to switch here. So digit, and either it's case case decimal point. We can get rid of this thing because compiler will understand what we have. So if it's decimal point, then we can just return string, which is decimal point. That's it. If it's number, again, we want to get the value from what is it is associated with. So number has integer. So we have our value, and we return string of that value. So this is the thing what you described, that we go to each of these elements and that's it. So let's see why it cannot. I think we need to tell compiler that it's going to return string. So using map, add here that it will return string. Otherwise, it's weird that the compiler doesn't understand it. And in the end, we have basically, let's take some space. So from this thing, we have converted at first all these values are not integers anymore, they are strings. So it's like this, 52, this decimal, then 4, and then 0. And there is nice function called joined. And if you type join here, returns a new string by concatenating the elements of the sequence. It means array, adding the given separator between each element. So we don't want to concatenate with, so we want to concatenate just empty value basically. And we have our join. And then we want our last step. So as we have this thing here, we want to create double. And there is initializer for double, and we just pass in our string. And as it is optional, so that's why we need optional here, because we have our strings, not string. So we, as it can be optional, because for instance, we have something like this. It cannot make double from SD. It cannot do it, so it will return nil. So that's why we have our optionality here. And before we go to the break, actually hold this thing. I just want to show you. So there is really nice function called reduce. So let me write it out. Reduce set strings, and I will explain while I write it out. Reduce, and if we jump into definition, hopefully it will load something and not crash my Xcode. So as we can read, the final accumulated value, if the sequence that is initial where it's written, what it's doing, returns the result of combining the elements of the sequence using the given closure. So basically, we combine array sequence in one value. So that's what it is. And we need to specify how we do it. And we need to provide our initial value. And initial value is just empty string. That's it. And then we go over each time. So we have our result, which in the first iteration is just empty. And then we have our digit. Again, we need to switch over our digit. And here we need to specify that it will be string. And case decimal point, we need to return new value. So what it is, we have our previous, in the first step, we have just empty. So we have our result, which is empty string, and we add decimal point. So plus means adding to the result to the first step, it's empty. And then each step we have 1, so we add 1, we add 2, we add 3 to the string. In that case, we have our number, which is that value, because we want to get that value. And then we add string value. So what it does, I can go over again. So we make here this. First step, it is empty. It goes here. It has 1. Okay, it jumps into here. It adds 1. Next step, it's not empty anymore. It's 1. It has 2. It adds 1 and 2. So together, then it's basically 12. So that's how it works behind the scenes, this reduce function. I encourage you to open Playground and just have arrays, and then you can see what it is in the end. So maybe during the break, while you have break, I will write one simple thing in the playground, and I will demonstrate how it actually works behind the scenes. But for now, I will comment that out because that's what essentially it does. Why a reduce here is better? Because here, what we do, we go over all the digits, and then joined goes over digits again. And as we jump here in this reduce documentation, we can see that complexity is just O(n). So basically, how many elements we have in array, that's the complexity. But about more about complexity, we'll learn in upcoming weeks in computer science thing, because usually we need to think how fast stuff can execute. Maybe we are creating apps when if in table view we have like 100 or maybe 150 values, or iPhones are so fast. But imagine you're creating something like a library of all your songs. You can have like millions of these things. So now, then you need to think more carefully if your apps are executing fast enough. So always try to think about the complexity. But again, that comes with the experience as well. So I didn't know that in the beginning myself as well. So don't worry that much. Just know that this complexity can be a term what you could be asked during interviews as well. So it's from the surface, it's always good to know that this thing exists. But like I told, you will discuss this thing in computer science lectures, I think next month or like that. So if I'm not mistaken. So now let's have a 5-minute break, and then we can continue. And meanwhile, I will create a simple playground with reduce, so maybe it will be understandable. I need to name my sound now. I hope you hear me. So let's continue. So, like I said, I wrote small playground, which I will add to the today's project as well, which I will archive. So as you can see, we have integers of 1, 2, 3, 4, 5, and we want to get 1, 2, 3, 4, 5 number like that out of it. I mean, in this case, actually string. So first one is I wrote it with reduce. So as it is, we can actually print out here even result print element. We run this thing again. So as you can see, first it was empty, element 1, and result was 1. Then element 2, result 12, because we added this 2 in the end. So that's what reduce does. And this map plus join is equals this reduce function here. So I will add today to the archive, so you will have this playground, so you can play around yourself, changing values in this array and whatnot, so you can experience that more. But we don't have time that much cover these things. So let's move further, and now let's create our calculator, which is kind of the main brain of the framework. So let's go ahead, add new file, again to the framework. So that's the third and last file today for our framework, Swift file, and let's call it calculator. And again, we want to be accessible from outside, so public struct. So we're going to use struct for that, calculator. And then we want to, again, it can be initialized from outside. So we want to explicitly tell that it's public initializer and nothing inside there, just empty initializer. So it can be outside. And next, we want to use our stack, because as we checked, a stack was not exposed from outside. So this calculator struct will use the stack behind the scenes. So to use the stack, we need to create private variable stack. Private because we don't want to expose that to outside. So it will be only for this calculator, and that's it. Then stack. And what we want to keep in the stack, we need to provide, because as here in the stack file, element was generic. So once we create the stack, we need to tell what we want to keep there. And we want to keep there type double, because we will, our calculator will use doubles. And let's initialize that with 2 empty doubles for now, so we can go ahead and use it basically, and we don't have any crashes. So maybe small homework can be get rid of this and make it more safer, but that's outside of the topic for today. And then next one, we want to push value to our calculator, basically to our stack. And then we want to add like a push operator, so plus, subtract, the multiple, divide, add, all these things. And then we want to actually do the calculation. So for that we need multiple things. So first is we want to push a number to our calculator. So let's imagine our previous example, or I can actually bring in app. So at first we want to add some numbers. So let's say 1, and then once we press this one, then it's added. So how we can going to do it? We need public mutating function, because we will mutate this calculator. Push. Again, we don't want to specify again the number twice, so we can have underscore and get rid of what we call it. And it's type double. And we just push to our stack. So if we have our stack variable, not the thing, and we have push, and right away we can just push the number there, and that's it. So we push a number onto the stack. And now we want to, in quotes, push operator. So basically operators are add, subtract, multiply, and divide. So public mutating func, because we want to change our calculator. Push, and what do we want here? What will be the thing? So we want our it will be operator, and it will be what type we can use here. Let's create a new type inside here. So it will be public enum, because we have multiple choices of operators. We cannot have multiple ones. We can choose only one. And again, if it's only one from something, it screams that it's enumeration. So operator, and we have add, we have subtract, we have multiply, and what else we can do with our calculator? Of course, we can also divide. And here we can use our type what we declared here. So I can write here calculator operations. Okay. So that's it. What you can do with that calculator, what we are going to do today. And then we want to remove 2 elements from our stack and use the operator. So for instance, let's say we have 1 and 2 in our stack. We want to remove 1, we want to remove 2, and then use our operator. So if, for instance, it's add operator, then we remove 1, we remove 2, then we add those 2, and it's free. So that's how it works behind the scenes. So we need to get element 1, so basically this one. And what it is, we just use stack pop, because it gives back the last value we added to our stack. So stack pop, and as it is optional, let's say it can be 0. It screams a bit for improvement, but for now it's fine. And then we want to get the element 2. So if we have removed 1, we want to get this one. Element 2, or second element, stack pop. So the element 1 is 1, element 2 is number 2. And again, we want to tell that if we don't have anything, we have 0. And then we want to calculate the result. So let's say result is going to be double, because if we kind of do some stuff, these operations with the doubles, it's in the end it's double. And then we want to switch operator over operator, because we have our add, subtract, multiple, divide. And here we see that this operator is the same color as switch, so something is not okay. And what it means is that this operator with a small o is actually used in Swift by this keyword. And how we can tell that it's not keyword anymore, we can use these ticks here, or how they are called precisely in English. Basically, it's not the kind of these marks, right? But it's these ticks. Are they called ticks? I hope so. Yeah.
Yes, they are.
Back
Yeah.
ticks, I think, is what I've heard.
Okay, backticks. Yeah. So using backticks for or for keywords from Swift. So for instance, if you want to use switch, like let's switch, you can go crazy and have this one. It's not kind of preferred way because it looks weird, but here it's fine because it's descriptive, it's operator. Of course, we can use like op or whatever, but I just wanted to show this neat trick that you can use these backticks. And then we need to case over what we have. So we can press here, add these missing cases. I think it's easier. Can get rid of this unknown default, and we can fill out all these add. So if we have add, then result is element 1 plus element 2. If we have subtract, then result is element 1 minus element 2. For multiply, same as add, so we have element 1 times element 2. And for divide, result is element 1 divided by element 2. And what we want to do is once we calculate, so for instance, here's 1, 2, we tell that this we want to add, so we remove 1, we remove 2, and 1 plus 2 is 3, and then we add back to the stack. So basically, after here, stack push this new result that we calculated. So if you have like 3 here, then again we can continue. We can add 5 and maybe times, so then it's 15 and so forth. So we can use our calculator again and again and again. So is this clear how it works behind the scenes? Okay, that's good. So, and also in this Wikipedia article, which actually I can add to the Slack thread, so you will have it. You can read like math problems, how to say, how it's used and why it's even invented. And what we want to do else, we want to get the top value. So let's have the public variable, not function, but public variable. So it's computed property. So in these cases, when you have just one value, you can use actually a computed property, not a function. It's just kind of simpler and more descriptive way. Using function, would be the same basically. Just more. This is more kind of style, which is appropriate to Swift language. So top value, which is optional double, because if you don't have anything in stack, then we have nil, right? And what is this? Stack peak. So remember, our peak was just to see, not to remove, just to see what's there. If it's nil or whatever it is, we want to see the top value, and that's it. So that's means top value. So we can write here just to view the top value in the stack. And also we want to clear or stack. So if we have something like that, we want to press this button here, and then it clears everything. So again, public mutating func, because we want to mutate our calculator, clear stack. And then we use our stack is empty, and that's it. So clear the stack. Okay. And again, I want to stress out that stack is internal inside this framework, but it is so we can use in our calculator. So to use the stack, we need to use the stack. We need to use the calculator. And this is how you can make these abstraction levels. So inside the framework, you can test the stack and all that stuff, but it's not exposed to outside. So sometimes you don't want to expose all the data structures and everything what you have in your frameworks. So for instance, you have Instagram framework, you have all these ways how to transform images which you took, but you don't want to expose to outside. So you can you use only inside this framework, and that's it. Or you have some kind of calculation, let's say Airbnb framework, how you calculate the price. You don't want to expose all that calculation. You just want to expose the end value. What is the actual result? So this is why you need these abstractions for the frameworks. So that's it from our framework. Once again, select here this RPN, not the calculator, RPN. Select one of the simulator, and now command build, or just here you can press build. So we are going to build our framework, and then we can use in our app. So once before we move to the app, are there any questions or comments? So now we're going to use this framework to create an actual iOS application. Any questions? Maybe I need to explain more something.
Can you just cover it real quick again? Why we made these functions in calculator and then also in, I think it was stack or
yeah,
digit accumulator?
Digit accumulator is publicly exposed as well, because we will use in our application to kind of create this text field. So digit accumulator will be responsible for this text field, right? And for calculator brain, we are going to use our calculator. But
Okay.
why not to expose stack outside? Because that's a one level deeper type which we are going to use behind the scenes. So there's no need to actually expose the stack. And it's actually preferred way to expose as minimum you need. Because if you, for instance, you use the framework, you see hundreds of functions what that framework has. You don't need all those. You just need to have the basic things to get it working, and that's it. So that's why, and also it was kind of goal of this lesson to show that something can be just inside the framework itself. So it's not visible by the iOS app once you import the framework.
Gotcha. Okay.
Yeah. So it's a kind of one level deeper per se. And here, maybe the array is kind of hidden underneath the stack, but array is provided by Swift and by Apple.
Thank you.
Yeah. And yeah, it's a really good way. If you create frameworks, expose only those things which you need. Don't make everything public. Make only those things which you need public, and that's it, nothing else. And it's easier by a framework consumption, those developers who consume this framework. Here we have just 3 files, but imagine Airbnb framework. There should be like most likely thousands of files, and there less stuff is there. It's easier to use it. Okay, so unless there are no questions, so we can move to our iOS application. So now, if we have built our framework, again, select here this RPN, press build, so it's built. Now select the calculator. So we will use our calculator, so we will work on our calculator app and create UI and connect our framework. So let's calculator, then whatever simulator we have. I will use iPhone 11. Then we have our view controller, and we imported our RPN. And once we have selected this thing, we can actually build and see if everything is fine. So we can import our framework. So for everyone, is it fine? You can import the framework like this, or there are issues? Okay. If there are issues, just shout, as I don't see actually everyone, because not everyone has enabled the camera. Anyways, if we have imported, then this view controller, let's try to rename it and make it more kind of descriptive. So let's jump here, refactor and rename. And let's rename to the calculator view controller. Let's see. So we renamed it to something more understandable. Otherwise, just view controller, like what the hell is it? We can get rid of view did load because we don't actually need it today. So it's not a requirement. You can actually remove this function. And as I showed you the app, the end app, what we need. So we need our text field, and then we need our numbers and all these operators to work. So now at first, let's go and create our text field. So this thing here. So it's IB outlet. We're going to use storyboards. Just at first, let's create the values itself in the class. So it's week var text field. Maybe it should be better name, but it's more descriptive for today, and it's UI text field and force and rapid, because otherwise it won't work. And then we want to create our calculator, and what it will be private in this class. It won't be exposed outside. So we can have computed property. So it's private var calculator, and what it is it is calculator type. And then we can specify, once we create the calculator, we can specify what it will be when we will change it. So once we change the calculator, we actually want to update value in text field. So we can use here did set. So once we set something in calculator, we also want to update the result in our text field. So when we add like 1, 2, and then we say that we want to add these values, we are changing also text field. And this is a great approach to do it here. So if let value, and now we're using our calculator. So calculator, and it's top value, because we're just checking what we have top value. We're not removing. So we get our top value. And here we just add to the text field text string the value. And else if we have nil, so we want to actually update the text field as well. So text field text is just empty, nothing. And we want to use our digit accumulator as well. So if we add more digits, for instance, we add 7, 8, 9. So we use our digit accumulator to accumulate all the digits. So we are using the similar as a calculator. So again, it's private because we don't want to expose to outside. Digit accumulator is digit accumulator. Then we create it. And then again, once it's set, so did set, once we change it, we want to get the value. So if let value, we have our digit accumulator. Here it's small letter, so be careful because it's a value that we're using here. And we have our value, and it returns the value what it has accumulated. So remember this reduce or joint, all that stuff. So that's the value that we have in our digit accumulator because it accumulates all the digits. And then again, text field text string, and we convert that value. And if there is nothing there, if it's nil, then text field text empty. But here is one thing. So let's imagine we divide something like that. So it will be really, I don't know what it be the result, but it might be after comma, something like that. So actually, we want to make it look more prettier. We don't want to show long thing because if you look here, you have space. So for that reason, we can create number formatter. And what number formatter does is it can format the numbers in specific way how we want it. And for that reason, we can create private let number formatter, which is type of number formatter. And here is one trick. We are using anonymous function. So what it means is that this number formatter is anonymous function because we don't have name here. And here we need to initialize, basically call the function. So it's an so it's called once and saved in number formatter. So here we create our let formatter number formatter because that's the type we need. Then we can return the formatter. But how we want to format or number? So at first we want that it allows floats. So as we can read, it determines whether the received allows as input floating point. So that's what we want because we want to show the doubles. So allows floats, that is true because we want to do it. And then maximum integer digits, let's say 20 sounds good for this UI. And then, so we can tell to our formatter maximum integer digits is 20, not 200. And then we want to specify how many of these fraction points we have. So let's say we have 20 like that. And how many we have after the decimal point. So I would say maybe 20 is up to 20 is fine. So we need to tell formatter minimum fraction digits is 0 because we want to show from 0. So if we don't have anything here, we can show just 20. So it's 0, and formatter maximum fraction digits is 20. So from 0 to 20. And now we can use our formatter here. So I will comment out just setting a string. And what we are going to use here, we're casting to NS number. So NS number is Objective-C type, and that you will cover most likely in coming weeks. So you want to use, again, text field, text, because we want to set the text field. And then using number formatter, we can get string value or value. But again, value is double, but it expects NS number. So we can typecast as NS number. So if you look into here, this number formatter string, jump to definition, it expects NS number. And if you jump into NS number, then there are multiple initializers. So we can initialize by integer, and there is double as well. And we don't need as question mark, just as, and that's it. As Swift types and objective types actually are can be typecasted quite easily, and Apple did it for us, thankfully. And we need to use it the same here. So text field text equals number formatter string value as NS number. So at first we cast to NS number, then we get the string using our number formatter. And what number formatter is, we specified here. So allows floats, maximum digits 20, maximum fraction points 20. So that's it. And now we want to create our functions, which are IB actions. Enter numeric digit and enter decimal. So basically, once we enter 7, 8, 9, blah blah blah, and also for the decimal point in 0. So let's call it enter numeric digit, and it's going to be UI button. So all these are buttons. So or sender is UI button, and to use our digit accumulator, we need we remember that it can throw. So using this add, if we go here again, here it can throw. So we need to specify that it can as it can throw. So we need tell try question mark, because it needs to try. Of course, here we need to maybe improve try catch, but for now it's fine. So digit accumulator add, and we add here number, and what number we add from how to specify which button is pressed. We can use this tag feature. So sender, which is button, has tag. And once we will create UI, I will show you how to use this tag thing, so it will be more understandable. But basically, if we jump to definition, okay, here is not that descriptive, but basically UI elements can have tags, so that can you specify what button, what UI view, whatever is there. So that's a neat way there. And we need to add func here, of course. And the next one is we want to enter our decimal number. So func IB action func save or enter decimal. Again, it's UI button. Again, we need to try, because it can throw. So digit accumulator add decimal point. So we don't need to use tag because it's just decimal point. And then we want to save, use our calculator. So IB action, save number to calculator. So basically, this button does the job. So once that one is pressed. So again, it's sender UI button, because that's the button we press. And then calculator, sorry, it's not that one. So save number. So when we save, we want to get the value from the digit accumulator. So if let value digit accumulator value, and then we add to our calculator brain. So what we have, so imagine we want to add the 7, 8, 9 pumps, we add it to our calculator. So calculator push value, and and after that, you see the text field was cleared. So digit accumulator clear. So that's the job there. Again, don't forget func here. And now we want to make our operators like divide, multiply, subtract, add, all that stuff. So IB action func add accumulated results. So that is our add operation. Sender UI button. That's UI button. So calculator push. And we want to use for operator. Why it's not popping up? To push operator is public function. Let's see. Yeah. So the Xcode didn't show me that option. So let's hope it will struggle to the end Xcode and not crash. And then we want to we can copy paste because we want for subtract, multiply, and divide. So we can rename this thing here as divide. Here it's divide. Then we have our multiply, multiple. Okay, I'll let it be like that. And then subtract. Yeah, I have typo here, but that maybe you can fix, or maybe you have correct typing as me. And what else we want to do? We want to implement this button here so we can clear our text field. And for that, we can use, we can create extension for our calculator view controller, which conforms to UI text field delegate. And for UI text field delegate, there is one function which is called text field should clear. And that is called when you have your text field as delegate. This function is being called. So what we want to do here, we want to clear stack for our calculator. We want to get rid of all our calculations that we have till now. Then digit accumulator, because if we have something here, we want to clear that as well. We want to clear our digit accumulator. We want to get rid of calculations. We want to get rid of digits as well in text field. And we need to return true, because that's a requirement for this text field should clear function. So we need to return true. So everything's fine. So Is this understandable once we go to the storyboard and create our UI? So essence here is that we are using our framework. So we're using our RPN framework, and we're not using, like, we don't have these files right in our project. So we're using digit accumulator, and we're using calculator. So digit accumulator for building this text field. Once we add like numbers here, like digits, like that, for instance, and calculator once we do the calculations. Okay, let's go to the storyboard. And right now I have, let me make it a bit smaller so we can see. It's just empty and nothing there. And let's add stack view there, so we can more easily stack our elements. So let's select vertical stack view. So we can add like that. We can stretch maybe like this. And then we can specify that, let's say, I know 20 is fine. And maybe here also, like maybe 10 here. Or let it be, yeah, let's 10. Add these constraints. It's red because we need to add our elements, then it will understand what it is. So we want to add our text field, basically this thing, right? Text field. Let's drag the here, bumps, it's there. Let's make it a bit bigger. So for our text field, let's bump up to, let's say, 42. Seems, yeah, it seems bigger. And also we want that our clear button here, it appears, let's say it's always visible, because we want to clear our digit accumulator and our calculator. So here, clear button, it will be always visible. And we can go ahead and set delegation. So control drag to our view controller and set the delegate. So we have our delegate here, and we have also our text field. So let's drag and drop like that, bumps. And now we have that thing. So now we need to add all the rest of the buttons like that.
Can you repeat that last part, please, with the delegate?
So what you can do is press here, control press on the view controller here, so that these kind of things pops up, right? And now from here, if you I can remove here, and if you drag from here, you just set that this text field, it will be that one. So basically we specified here text field, right? But we want to connect with the UI in the storyboard.
I got it. Thank you.
Yeah. So there are many possible ways you can, like, I don't know, drag and drop here and all that stuff, but I actually prefer this way, because here you can see what you have set already. Maybe you have set something twice, so you always see it here. So kind of it's like a good approach to check, okay, delegate, okay, view, all that stuff, okay, looks good. Otherwise, it's easy to miss in this storyboard thing, everything. And I usually miss many things, so that's why I kind of double check there. And now we want to create, yeah, like I said, these buttons. And what are those going to be? Those are going to be horizontal stack views. So we can stick here under our text field stack view. And then we need to add multiple buttons. So button let's add button here. And then there is one trick that you can control drag like that. Not option. It was option. So select this one button, hold option, and drag like that, and you will create a new button like that. So this is a neat way how you can make multiple buttons like this. And we need 4 of those. So let's see, we have like that. And for this stack view, we want to tell that it will distribute field equally. And we want to bump up this text because it's quite tiny, right? So at first, let's say our stack view gives some spacing. So I know 25 maybe. And then for all these buttons, you can select all of those at once, and we want to bump up, let's say, system semi, not semi-bold, but system bold, and size like 48. Something bigger. It doesn't matter. It can what the number put just something something bigger. And then these buttons are like, as you can see, 7, 8, 9, and then like this divide thing. So this first one is 7. Then we have 8. Then we have 9. And then we can actually add emoji. So divide. Let's say this thing looks good. Add. Let's see here. Maybe it's too big. I know. But I have actually the thing, one symbol here. Okay, I will copy paste that in our thread, so you can copy that symbol if you want to. And here there is this trick to set this tag what I mentioned. So if you select this button 7, scroll a bit down here, so this in this editing mode, and here you see tag, it's 0. So change it to 7, or 8, change to 8, 9, 9. And for this, so at first, let's create multiple stack views. So again, select this stack view, hold option, and slide a bit down. But be careful that you add not inside this stack view. So you add under, so you add in this main stack view. So it's a bit tricky to do, but essentially that it is. Now let's give the main stack view a bit spacing, so everything is not that cramped together. So we can change our distribution, fill equally, so it looks much better, and spacing maybe 15 might be good, so it looks much better. So we can expand our stack views like that. And then we want our second row, so that is 4, that is 5, that is 6. So here is times, so maybe like that, times. Did it work? Okay. That doesn't look that great, but okay. Then 1, then 2, then 3. Then we have here our decimal point, 0. And here we have our kind of enter symbol. So let's say we use emoji again, enter. You can expand emoji window here, so you can have actually more characters. So enter, or I actually have it here, so I will again copy paste and copy paste to the Slack, so you will have your UIs nice and clean as I do. And here we have our subtract, and actually here if you hold Option and press subtract, you have a longer sign a bit. It's a trick. And here this thing is just plus. And here we need to change our tags accordingly, because 4 the tag is not 7, so 4, 5, 6, 1, 2, 3. So be careful to set those tags properly, otherwise, and you need to remember for 0, otherwise it can be confusing why it's not working as it should. And now we need to connect these buttons, right? So I know, let's start with these operators. So control, drag to here. So we have here that is or divide accumulated result, bump. Then we have our multiply, so go over all the operators basically. So, oh, no, not that one. So tiny, multiply, subtract, add, and then this enter is or or save, that is, or save that is our save number to calculator, because we want to save the number to the calculator. And this one, did we add that one? Yeah. Then enter decimal, because point is enter decimal. So that should be that. 32. Hope we have everything. Let's see what we have here. So we have a text field, we have delegate, add number, add accumulated, divide, enter decimal, enter, and now we need to, so we have multiply, save, subtract, and now we need all these numbers. So that one, and add this enter numeric decimal. So we need for all of those enter numeric digit, how it was called, enter numeric digit. And as we have our tag there specified here, it will calculate properly. So it will understand what button is being pressed. So we're running a bit out of time, so I will do it quickly. So let's hope everything is set. So we have for 702. Oh, that should be fine. And as we have that one, let's try to, like the magic moment, let's try to run our app and see if it's working. And meanwhile, I'm open for questions. So let's see if it runs. So let's say we want 1. Okay, maybe we need to put in center that we can 1, 2, then seems working, and we can quickly fix our UI so this one is centered. So we want 5, add 6, add times 30. So did you get also working or any problems? As always, I will compress this thing and also the playground and add to the Slack, which I actually are doing right now. So I will not forget it. And meanwhile, you can ask questions. So I'm open for questions or comments or whatnot. Or you're so tired already and waiting for Christmas that no questions at the moment. Which is fine as well. I'm actually looking forward and quite tired as well. But anyways, I'm not tired for your questions. So
I just have an an error. It's saying that there's no instant, or I'll just show you.
yeah, just share. Maybe some other folks have it as well. So let's look at it together.
You're just saying unresolved identifier calculator, which didn't do it for digit accumulator.
Can you change? Yeah, can you change in calculator plus framework up where you have scheme? Go here. Change to this RPN framework and select one of the simulators. Yeah, and now just command build, command B. And can you show the calculator here, what you have there, so I can check if everything is, how to say, public, what it should be. Let me check from my code as well. So if I have, so public struct calculator, public init, okay, now if you select here again the main app, the calculator plus framework, and now command B, like just build. Let's see if it's again same error. Can you go to that file? Yeah. No, sorry. Let me clear my drawings. Open this file. Scroll to the top. You imported the framework. Can you go to calculator file? And can you expand here where it is actually? It is in, okay. Okay, that's weird. Can you show the error again? Okay. Now I think there is, can you scroll a bit up?
Oh, this one's spelled wrong.
Yeah, now, yeah.
It went complete earlier.
Yeah, that was the trick, that you need to change to the framework and build the framework. So framework is usually built separately. Now you need to return formatter here.
Oh, sorry, I keep moving. Oh, go back to formatter?
Yeah. No. I don't know. Scroll a bit up in this file. Here, you need to type return formatter, because you need, it's anonymous function which needs to return this formatter. So you need to return something. Okay, and what you have here, I think here is this spelling thing, right? Just type here calculator, maybe it will help you like that.
Okay, I said I had to build there. Okay.
Yeah, nice.
So this issue was just because I had to go and swap this a couple times?
Yeah, because you build separately framework from the main app. That's how it usually works. Because have you heard folks about Cocoa Pods or Swift package manager? Does it these terms make sense?
Yeah.
Yeah. So basically, if you use Cocoa Pod, it's separate framework as well. and you need to build it separately. So if you run install CocoaPods behind the scenes, it will get the code, it will compile, and then you can use in your app. So here it was basically that step what the CocoaPods is doing for you behind the scenes, because CocoaPods developers have done it for us, and we don't need to do this wiggling here and there every time.
Okay.
So yeah, using CocoaPods is basically using a framework, and maybe you want to export this RPN framework as CocoaPod and import as CocoaPod. So that's completely possible as well. Just right now, I think we don't have time for that to show everything. But yeah, that essentially can be done.
Okay.
Yeah. Any other questions, or I can explain once again something wasn't clear, or if everything is clear. So the kind of recap for today about the frameworks is that you can separate some portion of the code. Like I usually call it brains. So in this case, the calculator was our brains, and you saw the main app was just consuming this RPN framework. It didn't have like the knowledge how it actually calculates stuff. Everything was abstracted in the framework. So next step, of course, would be to create unit tests for the framework and maybe some other stuff, and also about this public and what is not public and what is public. So remember, make public only those things which you need to expose. Everything else, let's keep it private inside your framework and abstract it away. So let's imagine you have a colleague, you give this framework to a colleague, hey, use it, and they just need to know only those things which they need to use. So they actually wouldn't know about stack at all. They would just use our digit accumulator to have the text field, and calculator to calculate values, and that's it. They don't need to know either it's stack or array or what the hell is using the framework behind the scenes. So yeah, and it's a really great way to abstract, and as Swift is compiled quite slowly, if you have really huge projects and once you end in a job where you have millions of files, then by abstraction of these frameworks, you build them separately. As we checked this example where you can need to build separately. So once it's built, you're not rebuilding that framework every time. So actually, it speeds up the build as well for your apps if you have huge app. So imagine app by Airbnb. That's like huge projects, like enormous. And if you, I know folks working in Airbnb, even for them, clean build is, I think, like 7 minutes. And without separating into frameworks, that would be like 30 minutes. And also, some part of the company can make this framework, some part can make UI, some parts can make that framework, so you can separate concerns between your colleagues as well. And that's usually the case in big workplaces. So this kind of grasping knowledge of frameworks is really valuable as well. And all the UI kit is actually framework as well, or I know combined Swift UI, all those are frameworks behind the scenes. So yeah, that's I say it from my side, unless you have any questions. So I think I won't see you anymore, because I'm teaching only this kind of intermediate Swift. So you will go, I think, to Objective-C. So it was really great working with you. And if you have any questions, I'm always available in the Slack. So if you kind of deal in some other parts of your kind of career and also in Lambda School, always reach me out, and I'm happy to answer either it's Slack or my Twitter. So yeah, don't be scared of that. And yeah, Merry Christmas and Happy New Year. And I wish you luck in your opportunities and land a job, or I know, whatever you decide to do with this knowledge. And yeah, let's keep in track. So I'm always in Twitter, so you can find me there if you want to get hold of me. So that's it from me today, and have a great holidays, I would guess. Yeah,
Thanks,
see ya.
Vlad. Thank you.
Thank you. Have a good holiday, Chris.
Thank you.
Happy
Yeah.
holidays. Merry Christmas.